Itu kali. Wes tak kopi. Waduh, belum di oven. Assalamualaikum, Bu Ratna, kok gak nge background?
Sebentar, nggih.
Iya,
Iya,
iki aku mau ya utek-utek.
iya. Bu Susi ya?
Duduk
Eh,
Sumiati.
Oh, Bu Sumiati, ketemu lagi.
Iya.
Bentar ini aku ya. Setelah dikirimin Mbak Yusi.
Iya,
Sebentar.
cek tas.
Oke,
Nah, iku
ini
Basuki Rahmat itu.
berarti nang WA.
Nang BA, nang
Oke. Berarti gak iso nek.
Rektor of Universitas Trunojoyo Madura, Rektor of Universitas Negeri Manado, Rektor of Universitas Pembangunan Nasional Veteran Jawa Timur, Rektor of Universitas Musa Mus Merauke, Rektor of Universitas Kediri, Rektor of Universitas Pembangunan Nasional Veteran Jakarta, Chancellors of colleges in North Moluccas, the Vice Rectors, Deans, Heads of agencies, and Director of Postgraduate Program in Universitas Hairun. Vice Rector for Academia of Universitas Negeri Makassar, Dean of Faculty of Engineering Universitas Hairun, Dean of Faculty of Law and Social Sciences Universitas Negeri Surabaya, Dean of Faculty of Engineering Universitas Negeri Surabaya, Dean of Faculty of Mathematics and Sciences Universitas Negeri Surabaya, Dean of Faculty of Law and Social Sciences Universitas Negeri Makassar, Dean of Faculty of Engineering Universitas Trunojoyo Madura, Dean of Faculty of Law Universitas Trunojoyo Madura, Dean of Faculty of Social Sciences Universitas Negeri Manado, Dean of Faculty of Computer Science Universitas Pembangunan Nasional Veteran Jawa Timur, Dean of Faculty of Education and Teachers Training Universitas Musa Mus Merauke, Dean of Faculty of Engineering Universitas Musa Mus Merauke, Dean of Faculty of Engineering Universitas Pembangunan Nasional Veteran Jakarta, Dean of Faculty of Engineering Universitas Kediri, Head of Agency of Research and Community Services Universitas Negeri Manado, City Mayor of Tidore Island City, Dr. Rifai Umar MSI, Profesor Kufran Ali Ibrahim. And our keynote speakers, Profesor Dr. Hussein Alting SHMH from Universitas Hairun, Profesor A.P. Bayuseno from Universitas Diponegoro, Profesor Biswajit Pardan from University of Technology Sydney, Profesor Muhammad Aziz from Institute of Industrial Science, the University of Tokyo, Rizky Mardian PhD from University of Edinburgh, Mika Fisher PhD from the University of Hawaii at Manoa, Professor Frank Levin from Paris 1 Tertium Sorbonne University, Professor Bill Carter PhD from the University of the Sunshine Coast, Dr. Indra Kesumana Sution, advisor in ASEAN Nagoya Center, and finally all participants of International Joint Conference on Science and Technology 2021. Ladies and gentlemen, this conference is a joint international conference initiated by state universities across Indonesia. This conference is to bring together academia, researchers, practitioners, and policymakers to share their recent theoretical knowledge, research findings, and experiences in the field of science and technology. Many conferences have been carried out under the umbrella of IJCST, especially ICST, International Conference on Science and Technology, and ICSS, International Conference on Social Science. And this year, it is a big honor that this conference is hosted by Universitas Hairun in the City of Spices and Heritage, Ternate, North Moluccas. All distinguished guests, participants, ladies and gentlemen, we are now going to sing National Anthem of Indonesia, Indonesia Raya. All attendees in the room, please raise. Ladies and gentlemen, we are now going to watch a welcoming of Tari Rongge Salendang performed by Sanggar Seni Timur Jawa. This traditional dance is a heritage of North Maluku, representing relationship between human and maintaining. The Salendang scarf represents the bond between North Maluku people. This dance will be performed with live music from traditional instruments from Sanggar Seni Timur Jawa. Ladies and gentlemen, please welcome Tari Rongge Salendang by Sanggar Seni Timur Jawa. you very much for the beautiful performance. Ladies and gentlemen, now we are going to listen to report of the head of committee delivered by the Dean of Faculty of Engineering Universitas Hairul. Please welcome Mrs. Lita Asiriati-Laki.
Assalamualaikum warahmatullahi wabarakatuh. Yang terhormat Bapak PLT Direktur Jenderal Pendidikan Tinggi, Riset dan Teknologi, Kementerian Pendidikan dan Kebudayaan dan Riset dan Teknologi Indonesia. Yang terhormat Bapak Rektor Universitas Hairul, Bapak Dr. Hendrika dan Hukum, yang saya hormati Bapak Wali Kota Cilole yang berkesempatan hadir, para rektor, anggota konsorsium, para dekan, anggota konsorsium, para keynote speaker, dan yang saya hormati hadirin partisipan dari konferensi internasional on Science and Technology. Welcome to the 5th International Joint Conference on Science and Technology 2021 Sahid Bella International Hotel Ternate. Praise and gratitude that us together offer to the Allah Subhanahu wa Ta'ala. Thanks to them, so we can meet and gather together at the International Joint Conference on Science and Technology. This is an annual event, and this year is the 5th conference. This conference is a collaboration of 9 state and private universities in Indonesia who are a member of a consortium that organize international conference, namely Universitas Hairul Ternate, Universitas Negeri Surabaya, Universitas Gunung Universitas Negeri Makassar, Universitas Negeri Manado, Universitas Veteran Jawa Timur, Universitas Musang Merauke, Universitas Jakarta, dan Universitas Kadiri di Kediri. Ladies and gentlemen, the theme of this conference is advancing science and technology innovation on both disaster resilience and opportunity for everyone. This topic covers the prevention, mitigation, and education to natural disasters that occur frequently in Indonesia. This event aims to provide special contribution on our national development disaster resilience capacity. This conference also brings together leading academic researchers from various countries, share innovation, research, science, and technology to discuss the challenges encountered in this region. Ladies and gentlemen, currently the committee has received 2,092 papers that will be published at the Atlantic Press and E3S publisher. And this conference will held on 27 and 28 October 2021 using online platform and on-site. 9 keynote speakers from Indonesian foreign countries will deliver their papers in this forum. And in this special occasion, I would like to convey my sincere gratitude to the keynote speakers, Professor Alvin from Hairul University, Prof. Abe Bayuseno from Ecuador University, Professor Muhammad Aziz from Institute of Industrial Science of Tokyo University, Mika Fisher, PhD, from University of Hawaii at Manoa, United States of America. Rizky Mardian, PhD, from University of Edinburgh, Scotland. Professor Frank Lafford from Stoke. Professor Bill Carter from Science and Coast University, Australia. Dr. Indra Kusuma Nasution, Advisor Asian Nagoya Center Bank, and all presenters and authors who joined the conference. Pada kesempatan yang berbahagia ini, saya meminta dengan hormat Bapak Ahli dan Pendidikan Tinggi, Ristek, Prof. Hinjam untuk memberikan sambutan dan meresmikan pelaksanaan International Joint Conference on Science and Technology. Menutup laporan ini, saya ingin berterima kasih kepada Bapak Ibu anggota panitia yang telah bekerja mengabdikan tenaga, pikiran dan waktu demi terlaksananya konferensi ini. Terima kasih untuk semua anggota konsorsium. Terima kasih untuk Bapak Ibu dekan yang sudah hadir di Ternate. Terima kasih kepada pihak Universitas Hairun, pada Rektor Universitas Hairun yang telah membantu dan berkontribusi untuk kesuksesan konferensi ini. Dan terima kasih kepada pihak sponsor dan semua pihak yang telah bekerjasama untuk kesuksesan konferensi ini. On behalf of organization committee, I hope this conference is success and beneficial for all of us. Wabillahi taufiq wal hidayah. Wassalamualaikum warahmatullahi wabarakatuh.
Thank you, Mrs. Lita Asiriati Latif. Ladies and gentlemen, we are now continuing to the next agenda, that is to hear the speeches. The first speech will be delivered by Rector of Universitas Hairun. Ladies and gentlemen, please welcome Mr. Ida Ajami.
Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Good evening everybody. Selamat sore. First of all, we thank to God, Allah Subhanahu wa Ta'ala, who has given us the opportunity to be here and to attend this international conference. And I also welcome to every guest, every honor guest that has been in Ternate and maybe for the first time in Ternate or in the Nandas. I see here there are many guests from internal or Indonesia and also from outside abroad, and there are many also lecturers and dean, also the rectors that attend here, and also by or via virtual. And I think on behalf of the University or Higher University, I express my honorable, and I also, on behalf of the Civitas Academia of Higher University, I thank very much to the Dean of Technical Faculty of Higher University, and the committee that have already been held this conference. I refer my honor to the Director General of the Ministry of and Technology, Mr. Professor Yusrul Nizam, MSc, DIC, PhD, and IEU. There are also Rector of Universitas Negeri Surabaya, Rector of Universitas Negeri Makassar, Rector of Universitas Trunojoyo Madura, Rector of Universitas Negeri Manado, Rector of Universitas Pembangunan Nasional Veteran Jawa Timur, Rector of Universitas Musamus Merauke, Rector of Universitas Kediri, Rector of Universitas Pembangunan Nasional Veteran Jakarta, Chancellors of College in North Americas, the Vice Rectors, Deans, Heads of Agencies, and Director of Postgraduate Program in Universitas Cairo, Vice Rector for Academy of Negeri Makassar, Universitas of Negeri Makassar, Dean of Faculty of Engineering, Universitas Cairo, Dean of Law and Social Sciences, Universitas Negeri Surabaya, Dean of Faculty of Engineering, Faculty of Mathematics and Science, University Negeri Surabaya, Dean of Faculty of Law and Social Sciences, Universitas Negeri Makassar, Dean of Faculty of Engineering, Universitas Trunojoyo Madura, Dean of Faculty of Law, Universitas Trunojoyo Madura, Dean of Faculty of Social Sciences, Universitas Negeri Manado, Dean of Faculty of Computer Science, Universitas Pembangunan Nasional Veteran Jawa Timur, Dean of Faculty of Education and Teacher Training, Universitas Musamus Merauke, Dean of Faculty of Engineering, Universitas Musamus Merauke, Dean of Faculty of Engineering, Universitas Pembangunan Nasional Veteran Jakarta, Dean of Faculty of Engineering, Universitas Kadiri, Head of Agency Research and Community Services, Universitas Negeri Manado. There are also Professor Hussein Adi, the previous rector, and also my honorable guest, Pak Wali Kota Tidore, Mayor of Tidore City, and also Vice Rector of Academia, Pak Surahman, and the deans from the higher university. This year, it is a great pleasure for me that Universitas Cairo is the host for the 4th International Joint Conference on Science and Technology, or IGS. It has been an honor for Universitas Cairo to actively collaborate and join the consortium to hold the International Joint Conference on Science and Technology. I am very honored to have an opportunity to deliver this privilege for this conference held on the 27th and 28th of October 1991 here in Ternate, North. IGST has aimed to bring together leading academicians, researchers, scholars, and administrators from all over the world to exchange and share their experience research about all aspects of basic sciences, engineering, and technology, and discuss the practical challenges encountered and solutions. In this 4th year, the main theme of the conference is Advancing Science and Technology Innovation on Post-Disaster Relations Challenges and Opportunities for a Better World. I can see this year's theme as relevant topic as we enter the next normal due to the COVID-19 pandemic, which has affected all of our lives. Hosted by the Universitas Cairo, this 4th IGCST will be run in hybrid mode, where some keynote speakers, presenters, and participants join the conference online, while the others physically presenting their papers on the conference venues. Whichever they choose preferred mode, I greatly appreciate and grateful for the participants in disseminating new knowledge and experiences as well as their latest work. I should then extend a warm welcome and gratitude to all of you. Finally, I would like to congratulate all the IGCST participants. Please use this opportunity to networking with others, sharing ideas and knowledge while increasing our sensitivity to the social well-being among us. Enjoy the conference and enjoy Ternate. Thank you. Assalamualaikum warahmatullahi wabarakatuh.
Thank you for the speech, Mr. Rida Jam. Ladies and gentlemen, for the next speech, we would like to invite the Director General of Ministry of Education, Culture, Research and Technology to deliver his speech and officially open this conference. For this speech, the speech will be delivered from a recorded video.
other and enrich our knowledge about disasters and how to reduce the risk of disasters and make the community more serious to disasters. So I would like to once again appreciate all the distinguished speakers and participants to this international conference, and wish the conference a fruitful, and enrich our Assalamualaikum warahmatullahi wabarakatuh. Shalom, shalom,
These are our candidates for the speech from Mr. Nizam. Ladies and gentlemen, we are now moving to the next agenda, which is signing of memorandum of understanding by the directors, members of the consortium, and signing of memorandum of agreement by the deans, members of the consortium. For this agenda, we would like to invite Rector of Universitas Hairul to come forward. We would also like to invite Rector of Universitas Negeri Surabaya, Rektor of Universitas Negeri Makassar, Rektor of Universitas Brawijaya Madura, Rektor of Universitas Negeri Manado, Rektor of Universitas Pembangunan Nasional Putra Jawa Timur, Rektor of Universitas Musa Merauke, Rektor of Universitas Kediri, and Rektor of Universitas Pembangunan Nasional Putra Jakarta to get ready for the signing virtually. We would like to also invite the deans, members of the consortium, for the signing of memorandum of agreement. For this agenda, we would like to invite Dean of Faculty of Engineering, Universitas Hairul, Dean of Faculty of Mathematics and Sciences, Universitas Negeri Surabaya, Dean of Faculty of Social Sciences, Universitas Negeri Manado to come forward. And for the other deans who can sign virtually, would like to invite Dean of Faculty of Law and Social Sciences Universitas Negeri Surabaya, Dean of Faculty of Engineering Universitas Negeri Surabaya, Dean of Faculty of Law and Social Sciences Universitas Negeri Makassar, Dean of Faculty of Engineering Universitas Trunojoyo Madura, Dean of Faculty of Law Universitas Trunojoyo Madura, Dean of Faculty of Computer Science Universitas Pembangunan Nasional Veteran Jawa Timur, Dean of Faculty of Education and Teachers Training Universitas Musamus Merauke, Dean of Faculty of Engineering Universitas Musamus Merauke, Dean of Faculty of Engineering Universitas Pembangunan Nasional Veteran Jakarta, and Dean of Faculty of Engineering Universitas GAIRI to get ready to sign virtually. Ladies and gentlemen, for this signing, there will be a witness from City Mayor of Tidore City as the witness of this signing. Therefore, we would like to invite City Mayor of Tidore City to come forward. For directors and deans, please hold a photo session. Thank you for all directors and deans. Ladies and gentlemen, we are now going to pray. Let's wait for the company to prepare for the praying. The praying will be led by Dr. Agus Haji Usman Muhammad. Please welcome Mr. Usman Muhammad for leading us in prayer.
Hanya saya marilah kita menundukkan hati dan kepala kita sejenak. Kita berdoa semoga pelaksanaan kongres internasional ini bisa berjalan dengan aman dan lancar. A'udzubillahi minasyaitonir rajim. Bismillahirrahmanirrahim. Alhamdulillahirabbil alamin. Hamdan na'amin hamdan syakirin. Hamdan yuwafi ni'mahu wa yukafi mazidah. Ya Rabbana lakal hamdu kama yanbaghi li jalali wajhikal karim wa azimi sultanik. Allahumma shalli wa sallim wa barik ala sayyidina Muhammadin fil awwalin wal akhirin. Wa sallim radhiyallahu ta'ala an sadatina ashabi Rasulullah ajma'in amin ya rabbal alamin. Allahumma ij'alna ma'ana hadha jam'an marhuman wa tafarruqana min ba'dihi tafarruqan ma'suman. Allahumma ya Allah, puji dan syukur hanya hadir di sini untuk melaksanakan acara pembukaan konferensi internasional kerjasama tentang ilmu pengetahuan dan teknologi. Begitu ya Allah, kami berdoa semoga pelaksanaan konferensi ini berjalan dengan aman dan lancar. Jadi kalau pertemuan kami sebuah pertemuan yang senantiasa mendapat naungan rahmat dari Engkau, dan jadi kalau perpisahan kami setelah konferensi ini adalah sebuah perpisahan yang terdiri dari segala perbuatan dosa dan maksiat. Allahumma ya Allah ya Tuhan, berilah petunjuk kepada seluruh peserta yang mengikuti konferensi ini, agar mereka mampu menghadirkan pikiran-pikiran yang baik untuk pembangunan bangsa dan negara ini. Tunjukkan kepada kami dan kepada para peserta semua orang yang benar itu benar, dan berilah petunjuk kepada kami semua ya Allah, agar kami mampu mendekatkan dan melaksanakan yang benar itu dalam pelaksanaan tugas dan pengabdian kami. Tunjukkan kepada kami semua ya Allah, terutama kepada seluruh peserta konferensi dan kami semua, bahwa yang batil itu adalah batil, dan berilah kami petunjuk agar kami mampu menjauhkan diri dari segala yang batil itu dalam hidup dan kehidupan kami. Allahumma ya Allah ya Tuhan, setelah konferensi ini kami mohon kiranya kehidupan kami, ilmu pengetahuan kami, teknologi kami untuk memberikan manfaat kepada masyarakat dan bangsa ini semakin baik dan semakin bagus. Tanamkanlah ke dalam hati dan sanubari kami semua ya Allah, sesungguhnya hidup ini berjalan terus, dan kami punya prinsip hari esok harus lebih baik daripada hari kemarin. Hari ini lebih baik dari hari kemarin, dan hari esok lebih baik daripada hari ini. I must the hope and believe that tomorrow will be better than today. Allahumma ya Allah, hanya Kau lah tempat kami semua, dan hanya kehadirat Engkau tempat kami minta dan memohon. Rabbana atina fid dunya hasanah wa fil akhirati hasanah wa qina adzabannar. Subhana rabbika rabbil izzati amma yasifun wa salamun alal mursalin walhamdulillahi rabbil alamin. Terima kasih.
Thank you, Mr. President. All the distinguished guests, participants, ladies and gentlemen, we are now at the end of the opening ceremony of the International Joint Conference on Science and Technology 2021. Let us all be guided by all the things we are going to learn in this conference. We apologize if there are any mistakes throughout this event. Thank you for your attention. Wassalamualaikum warahmatullahi wabarakatuh. Peace be with you and good afternoon. Kepada para tamu undangan, kami undang ke depan untuk melakukan foto bersama. Kepada para rektor, anggota konsorsium, rekan anggota konsorsium, Bapak Wali Kota Tidore, para keynote speakers, kami undang untuk maju ke depan untuk foto bersama. Bapak Ibu kami persilakan untuk naik ke atas panggung saja karena dia Selanjutnya lebih kelihatan atau bisa dilihat.
Fokus kamera 3, 2, 1. Satu lagi 3, 2, 1. Oke.
Foto bersama berikutnya dilanjutkan dengan para panitia. Para panitia kami undang ke depan untuk foto bersama. Bapak Ibu panitia, Fakultas Teknik Universitas Palu, kami bersama untuk maju dan foto bersama.
Siap, 3, 2, 1. Sekali lagi 3, 2, 1. Kayak bebas. 3, 2, 1. Oke.
Bapak Ibu yang terhormat, untuk para peserta conference, ruangan untuk ICSS itu sebelah kiri dan ruangan untuk ICST itu di sini. Untuk sesi selanjutnya kita akan mendengarkan paparan dari para keynote speaker. Jadi untuk ICSS Social Science itu sebelah ruangan di sebelah gamma B, yang ini gamma A. Jadi untuk gamma A Social and Teknologi itu di sini, sedangkan untuk Social Science itu di ruangan di sebelah kanan.
Mohon perhatian bagi peserta ICSS, kami mohon dengan hormat untuk bisa berpindah ruangan di gambar C, tepatnya di sebelah ruangan di acara pembukaan ini. Sementara untuk partisipan ICST tetap di tempat karena sesi presentasinya akan dilakukan di ruangan ini. Terima kasih.
Mana kita presentase? Baiklah.
Kalau gitu mereka baju begini. Iya. Baju seimbang yang penting.
Betul. Bagi bagus. Foto memang gitu biasanya. Iya.
Bala.
Saya siap. Udah jauh siap. Gelah kok Pulau Jolo siap dengan video.
Dia juga ada yang baru kan. Ini ada yang nanti ada yang
minum.
Sekali lagi Bapak-Bapak yang social science mohon pindah ke gedung sebelah, dan untuk social and technology bisa stay di gedung ini karena sebentar lagi kita akan memulai sesi keynote speaker.
dan para peserta silakan masuk. Kita akan segera memulai untuk sesi keynote speaker.
Science and Technology for the 5th in this Ternate. For the first part, I would like to invite Mr. Moderator Maulana. Please welcome. Time is yours.
Assalamualaikum warahmatullahi wabarakatuh. Ladies and gentlemen, now we are entering the second session of the keynote speech. Please welcome Professor Antonius P. Bayuseno from Universitas Diponegoro. Used to be called as Professor Bayu, is an expert in material science and engineering at the Department of Mechanical Engineering at the Diponegoro University. He received a Bachelor Engineering degree in Mechanical Engineering from Gajah Mada University, Master of Science Engineering Applied Physics from Sultan University, Western Australia, and PhD in Mineralogy from the Ruhr University of Bochum, Germany, respectively. His teaching interests in ceramics, material science, and engineering. Research interests cover many aspects of ceramics design, applied crystallography, including the new material synthetic and characterization, as well as waste processing. But now, he will talk for us here in the room and in the Zoom meeting about progress research on reverse engineering to support national health industry. So, Professor Bayu, we only have at least 4 to 5 minutes because the limit of the time of the opening ceremony. So we will continue after this with another three speeches from Zoom. So without limiting any time, give the time for you for at least 20 or 30 minutes.
Thank you, Mr. Maulana. Dear participants, good afternoon, ladies and gentlemen. I would like to thank the Faculty of Engineering Universitas Cairo who invited me to become keynote speaker in this afternoon. I would like to describe or a little bit sharing experience.
Please share the screen. For the operator, please see the screen of the material of Professor Bayu.
Sebentar ya.
let me stand up. I'd like to little bit sharing my experience. What is the important thing from the reverse engineering, from 3D mesh to ceramic product. We have some picture here. We have some project that has been developed in our research group. For example, this is a teapot coming from the ceramic material. No move. Yeah, actually we have some focusing of the topic of our research, mainly from the ceramic product design, from the Tupperware, from jewelry, tile wall, toys, etc. This, we consider that there is an important product in our research group in the moment to compete freely in the area of industry 4.0. Next. We have some collaboration research with some ceramic industry, national industry, which produce some teapot, this kita data Indonesia. Mainly we have to have how to design the teapot with some software tool, especially how to make the pattern of ceramic, that we can see that there is a Miranda principle or T41 that with the different color and also have the different motif. Because we consider that Indonesian has a special, unique pattern, especially for example from batik or also from maybe some view in our life that we can adopt this picture to be our ceramic product. Next, please. This actually we have the consideration that there is a supply chain in this Miranda cap. It's really that what's the problem when we use the reverse engineering, especially how to import the design of the ceramic to be mass product. Next. Yeah, we have that reverse engineering is one of the methods in this design, especially, for example, in the ceramic processing. It means that we have now that there are defects in the ceramic product because of the incorrect dimensional product that make the product maybe some failure. So this means that we have to how to improve the quality of the ceramic to be the competitive product. Next, please. Yeah, this is the architecture of the CARE system. CARE is mean computer-aided reverse engineering system. That all of the processing design use the software in computer. And you can see that we start from the 3D scanner. Means that, for example, if we want to make some jewelry or some tableware, we need to scan first how to get the dimensional and also the geometric modeling of the product. From the scanner, we can export of the data into the generated STL file. We have to make this STL file to make from the qualitative data to be the quantitative data. It means that, for example, we want to make some teapot. We need to know about the geometry and also the dimension. So from the scanner, you need to do some generate file and to have the specific geometry and specific measuring data. We can see from this our schematic diagram from the part design, and then need to do some redesigning. So next we can see this some manufacturing technology. So from the computer, then we can change, can export into some computer natural computer ID design, and then we can change it again to be the CNC machine. Yeah, from the CNC machine we can make product from the data that we can export from the scanner. However, this process sometimes we have need to some new approach. Not only from the CNC machine, sometimes we can also use some another, for example, using the 3D printing or some another method that we can use. The important thing is that we need to the exact data of the geometry and the digital data of the probe. Next. Yeah, this is our product that has been produced for our processing method. This is from Minanda Care T41T4. For example, this sample product on the market at the moment. And the right hand side, you will see that 2D and 3D CAD model. This is from 20,000 Indonesia, and we use our software from this create this geometry data. So from the scanning, now that you can finally have some the ceramic product that can be sold, and then we can come with the other industrial ceramic product. Next. Now, you see that what the important problem from this data scanner is we need to the accurate data. From the qualitative data to be the quantitative data. So sometimes, for example, we have measure some height or length. There is the little bit different between from the real product and from the scanning product. Yeah, this is sometimes little bit that this is the important how to use the software in order to reduce this problem from the different of dimensional accuracy. Next, please. Now, you see that this is the process representation with the CMM scanning. Start from the physical model. This is from the market model. So, for example, if we have already bought some ceramic product from China or from another country, that we need to know or we need to mix new product with the similar quality of the similar dimension. What we have to do first is this product we can make the difference. It means that we did reverse engineering. So this is the physical model for the market. Then we put into the one coordinate measuring machine. In that machine, we can measure what is the geometry and what is the So what we have from the scanner, this is started from the 4 component of Miranda 34. Then we have to the different pattern here. For example, from the hand and from the top and the bottom here, and this is the hand, and you see that so complicated of our processing in the output representative from the 3D scan. Next please. Yeah. Now it's coming to also another 3D CAD files Miranda scan. This is part of the Miranda CAD here also, and also here. There is a different part of our representing process that to make the product component. Next please. Yeah, also some example here from the STL model from the scanning process. For example, this is the shape frame of the scope, and the other scale is the problem. Yeah, this is the part of our generate file from the scanning, and you can see that there is some problem how to make the generate the geometric modeling here. There is some surface of mouth from the result, and need to do some more finalized, more smooth. Now, this is the result how to the selection tool, and the result we have to more finalize of the program. Next please. Yeah, another example here when we want to make the 3D CAD file style like this one. Sometimes we need to first like this one. Next, and this one, yeah, this is the final result of the surface. Yeah, this is part of our work of the computer-aided design. Maybe some participant here recognize how to process and how to generate a geometric file from the scanning. This is the part of our process in the 3D CAD process. Next please. Yeah, here another example here also. For example, from the STL model scanning. From the scanning like this one, and we can generate another file for the state frame of the handle, and next we can do the state frame of the handle also like this one, and finally here something feature and the program. So you need to focusing on the different steps here in order to get the exact geometry file. Next week. Yeah, this is another also problem when we merge some model from the scanning process here in part of the top. Yeah. You need how to communicate here to make some model from the keyboard like next week. Yeah, this is 3 model for Miranda 30, one keyboard with consumption 11.7% from the individual country. It means that we are not appropriate from the different shrinkage due to the different size of the shape. Next week. Yeah. This is one of the 3D CAD model from Miranda 30 for one keyboard. X please. And also you see this is for handle and the top, and so that the different varying geometry in the 3D CAD model. Next please. Yeah. Here also can use for the different part of the keyboard. It is when we have data, geometric data, then we can export into the machine data. Yeah. This is the pattern that we can obtain by GNT milling. This one. This also. This is the pattern that we can see that from the GNT machine, from the scan pattern that we can make pattern Next, please. Yeah, finally, we have also this some final dimension in the 3D CAD program. You see that height, for example, 3D mesh is made different from the 99 to 3%. Then increase with 99.54 millimeter again. This is file size is mean that product after firing. In the ceramic processing industry, mainly that the product should be go to the furnace to be made solid, because this is the firing process. Next please. Yeah, this is the another step that you can see from the 3D CAD model, setting from size, then come to the pattern setting process. This is part of the machine. Next, and then we can how to set up the toolpath strategy. In the CNC machine, we need to do some cutter setting and also to do some toolpath strategy in order to reduce the machining time. And this, we can also use some simulation process from computer-aided manufacturing, step and step process like this one, and come to the 3D solid model output. Now, yeah, this is can use the NG code, numerical control code. Say that, yeah, can practice in the machine. That when we have program as well, that we can make our processing to be mass product, because we have already got the NG code data. Yeah, this is the state of our component graphic care for one keyboard, and this is for this keyboard, and the keyboard, and etc. Next please. Yeah, this is what pattern that we have already produced. This is another all captive mold from the Niagara, and this is also our pattern. This is pattern for the handle of the keyboard. This means that to produce some Niagara, we have some different mold. This is some type of handle for the mouse, and another part. Next please. Yeah. We want to summarize our state of the processing method of the ceramic, from the scanning, convert to the mesh, CAD to CAM, manufacturing master product, etc. And then we have finally some part of the keyboard, a handle, another part, like this one. This summarize the total time how to make the keyboard. For the part was 75 minutes, total time 58 hours. This is total time for 1 hour for this one, and total to produce some here also this is 24 hours. This means that only one product needs some the long time. If we don't use the CNC machine, maybe the product is not competitive with the other product, because we produce in the long time. Next week. Yeah, I think this is a similar product. Next please. Conclusion that reverse engineering process using CAD system, computer-aided reverse engineering, one of successful the method that can be applied for manufacturing of the ceramic product. In more depth research, however, we need some further application of reverse engineering to the use coordinate measuring to make geometric model of the keyboard. Finally, next week. Yeah, we have some also publication of our research work, especially for the report. Yeah. This is recently published in the Open Engineering 2021 and following some mainly focusing on the reverse engineering from DTMAX to the surrounding program to the form of Iran. Please. Thank you for attention. If you have want to know about what I have done, what we have done, what we have produced our product, please don't hesitate to raise your question. Thank you, and return my time to my moderator.
Thank you very much, Professor Bayu. I get some information from the community that you are in the time for the test, because it's already 3:50. So we continue to our next presenter or our final discussion, as is mentioned in the schedule. Professor icst2021 from University of Technology Sydney. Are you there in the Zoom?
Yes, I am here, but actually it's very noisy. I can hear a lot of noise coming in. Can you all hear me? Hello, can you all hear me? Hello? Hello? Yes, I am here, but
yes, thank you.
Hello, can you all hear me? Hello? Hello, can you all hear me? Hello, can you all hear me?
Sorry.
Education.
Education. Okay. Everyone here has a clarification for the presenter. Ada yang belum dilanjutkan presenter kedua. Karena presenter kedua sedang disesuaikan dengan dari Zoom. Maka sudah siap. Di sini sudah siap lagi. Profesor icst2021 from University of Technology Sydney will talk about partial prediction of natural hazard using machine learning and geocomputation, contribution to vulnerability and risk assessment. In the Zoom it already appears in his presentation, but here in the Kamala room, not appearing yet. Jadi Profesor Pradhan sudah siap presentasinya yang lebih. Jadi ini sudah muncul lagi di dalam ngobrol. Di layar Kamala yang muncul. Okay. So Professor, now is your time.
Okay, thank you very much. Can you all hear me? Because I can hear a lot of background noise, very noisy. Can you all hear me? We can hear you. You can hear me. Okay. Thank you very much. Because I cannot hear anything. I hear a lot of background noise coming from the, I think, conference venue. Okay, thank you very much for inviting me. So today I'm going to give a talk about partial prediction of machine learning and geocomputation. So I'll be talking more about the contribution towards the vulnerability and risk assessment. So how to use actually the geospatial technology in the vulnerability and risk assessment. This is what is my talk is going to be. So my talk outline is basically has three major components. So I'll be talking a little bit about brief background about emerging technology for natural hazard assessment that is currently being employed. So I'll be giving a bit of introduction to the geospatial computing and the various types of computing. Hello, can you all hear me? Can you? I'm not sure whether you can hear me or not.
Yes, Professor, we can hear you.
Okay, that's very good. Because I can hear a lot of noise coming from there, so I can hardly hear anything. Okay, so also I'll be talking about some selected case studies from my own research work. So I'll be talking about some case studies from Indonesia, focusing on the hazard vulnerability assessment, landslides, and also some case studies from coastal disasters as well. And then I'll be giving my concluding thoughts on this talk as well. So this is the university that I come from, University of Technology Sydney, which is at the center of the Sydney metropolitan city. As you can see, this is where actually my university is located at. So let me just talk about what are the disaster types. You know that if you want to talk about the disaster, basically you have natural, human-induced, and the man-made, right? But and again, we have also the meteorological type of disaster. We have geomorphological, geological, ecological, and various types of actual disaster that is existing. So, but as we know that disasters are almost never being natural, but causes can be natural actually. But today in my talk, I'll be giving it, I'll be touching upon actually some of the applications from floods, from the geomorphological or geological type of hazards such as earthquakes. If you look at actually, this is the very interesting map that I would like to share with you. As you could see, this map shows the global hazard map for the different types of hazards. It shows the earthquakes. That means the entire world has been classified into different earthquake probability zones, zone 0 to zone 4. And then you have the volcanoes and also the tropical storms and etc. The reason why I have selected this particular slide is very interesting because these kind of maps are very useful basically to determine or to explain actually where a particular type of hazard will occur in the future. So now the question comes how to prepare this kind of hazard map, because once we come up with a hazard map, then you can do a detailed vulnerability and risk assessment, whereby you contribute actually for the disaster mitigation and disaster management. So to ask these questions or to prepare those kind of maps, there are many questions that actually we need to address. And these are some of the questions, important questions that I listed up here. For example, where did the hazard occur? Where has it previously occurred? What is the type of hazard that we are talking about? How often do they occur? And why did they occur here? And what are the main causes of this type of particular hazard? And how we can map them, right? Like what actually I have shown them. And where will they happen in the coming period? How frequent will they happen? How big? Is it going to be big? Is it going to be small? Is it going to be in a regional scale? Or is it going to be localized scale? And what would be the expected damage? And where exactly it is going to occur, especially in the spatial temporal domain? And can we do something? Can we prepare actually some mitigation strategy so that we could decrease the expected damage? So these are the key questions that need to be asked before we could actually prepare those sort of maps. So the next thing that we would like to do is basically the input data, which is required actually for the natural hazard analysis. So, and the most important input data would be the type of hazard that we are studying. For example, if you are studying earthquake type of hazard, that needs actually different input type of data from the flood or from the landslide type of hazard. And also what is the type of analysis method that you are going to be using. Maybe you are going to use probabilistic method, or are you going to use actually complex methods or machine learning method or so on. And what is the scale of the study? So are you going to talk about the regional scale? Are you going to talk about in a localized scale, and the availability of resources and so on? So these are the important questions that actually need to be asked before we could actually do the natural hazard analysis. So now let me just talk upon a little bit about the emerging technologies that is available for the natural hazard. So if you want to talk about it, the geospatial computing, basically it has three important major pillars. One is the remote sensing, GIS, and the GNSS. So depending on actually the amount of technology that is being used, so basically the different types of terminology that is being used in the literature, for example, geoinformatics or maybe cartography or computational or geocomputing. But overall, actually, the geospatial computing basically depends on these three major pillars. So now let me just talk about what is geospatial computing. Geospatial computing is nothing but a set of computational tasks that involve actually geospatial data. Geospatial data is nothing but the information. So when you talk about the geospatial data, that means that refers actually to the information that is partially referenced with respect to the Earth. That means the data has actually geographically referenced data. And the geospatial systems have been conceptualized as having two basic kind of components. One is the spatial structural components, another is spatial interaction component. So basically it is all about the data, spatial data, and how the data has been captured and what are the spatial relationship between the data. So this is the important key aspects, especially in the geospatial computing domain. So when we talk about the geocomputing basically it is being managed acquiring data or information. So basically we are having a lot of data coming from the different source, maybe from the outside source, or maybe the data that we are actually generating from the project organization. So all these acquired data need to be computerized, and then we apply actually different sets of models or methods, generic methods, to produce different products, such as map, or maybe such as IoT-based actually informations, or maybe like real-time forecasting tools and so on. And also we know the computational models. Computational models is basically a set of computational operations which is performed in an order to generate a pattern. So given a set of data, so how actually we could infer some sort of actually pattern from the given data, so that we learn from the data, and based on the learning we could predict actually if similar set of environment appears, so that we could be able to predict them. So today we are talking about the new age of remote sensing. So because we are having so much of data available, the drones are available, the microsatellites are data available, and so much of high spatial resolution data is also available. So many sophisticated statistical machine learning tools are also available, and so basically open source data is also available, and the softwares are available. That is very, very key actually to perform the geohazard modeling and actually the risk and vulnerability assessment. So these are some of the slides that I would like to share with you. For example, this is the drone image, and drone images basically allows us for faster data collections, and also so that we can use them for better emergency planning as well. Airborne laser scanning data, or what you call the LiDAR data, this is also getting very, very popular these days, because this collects the data which at very, very accurate elevation data at a very fine resolution scale. And this is very essential actually for better feature extractions, mapping, and spatial assessment as well. So these are actually some sort of a very key, what you call different types of geospatial data that I have combined here. For example, the UAV data, or unmanned aerial vehicle data, then the LiDAR data that you could see on the right hand side, then the Google Maps and the synthetic aperture radar and LiDAR data. So much of data is being available today. So now the question is how we could use this data to make use of this data, and so that we could produce actually vulnerability and risk assessment, so that we could prepare some early warning tools actually for disaster management. GIS is also getting very popular these days, and I think in every organization these days actually they are using GIS, and GIS allows us actually to capture, store, query, analyze, display, and do all sorts of modeling and predictive tools actually for disaster management as well. So if you want to say, so the technologies are really advancing because we have so much of high resolution available data that is being available today, and a lot of better temporal coverage is available. So that means the data can be captured actually at any time using, for example, drone, UAV, all those sort of actually remote sensing tools. And also the data, the storage of the data is also decreasing slowly. And the more intelligence, AI-based algorithms also available, getting available in our hand today, so that we can quickly process the data. And also we could produce actually very meaningful products. Those can be useful for disaster management as well. So the second part of my talk would be actually the modeling approaches. That means because today we are talking about using the machine learning and the advanced analytical tools, which are getting very, very popular actually in disaster modeling as well. So machine learning and AI algorithms are basically the method of data analysis that actually automates the analytical model building process. So it is nothing but actually is a branch of AI or artificial intelligence, in which actually the idea the system can learn from the given data. That means if you have actually a lot of data, so we can build up a system, we can develop actually an algorithm from which the algorithm can learn from the data, basically actually creating some sort of pattern from the data and make decision actually with minimal human interventions. So basically this helps us actually to automate the process so that it can allow actually to deal with very complex data, very complex meteorological, hydrological, geomorphological, and all sorts of data. So these are some of the common AI models that is being applied today in natural hazard modeling. Some of them are like ANN, artificial neural network models. Deep learning is getting very popular these days in the last 5 to 7 years. And also the combination of so many other types of models like ensemble models and so on. So now the question is that actually having learned about a little bit about this remote sensing and geospatial tools and techniques, so that actually we can also see that there are a lot of data that can be also derived from this remote sensing and or by field surveys. For example, geomorphological data or anthropogenetic data or geological data, or many hydrological information, vegetation, distance. So all this data actually can be derived for such as, for example, DEM, digital elevation models, or slope and land use. Land use also can be classified from the very high resolution satellite images or maybe from drone images. Then the vegetation density and so meaning to say that all those sorts of data that is being basically the factors which are being conditioning factors that is being used for natural hazards, they can be derived from actually remote sensing source data. So once we collect this data, then we can actually do the modeling process, try to understand actually the relationship, spatial relationship between these parameters, and also the relationship between the historical inventory, if that is available for a particular type of hazard. In this case, for example, landslides, floods, or maybe earthquakes, or any type of hazard that we are talking about, then we can establish actually, or we can build up on actually some quantitative based prediction models such as machine learning models, and we can perform the analysis in GIS to produce actually very high quality actually spatial probability map that can be useful for hazard and risk analysis. So the third part of my talk that I'm going to talk about some of the selected case studies from my own research. So so this is where actually I'll be giving some examples from earthquakes, landslides, then also floods, and then some coastal type of disaster as well. So let me just actually try to show you some case studies from earthquakes. So because this conference is being held in Indonesia, so I thought that earthquake is a very, very common type of natural hazard actually, you know, that is the Southeast Asia that has been facing. So this study would be interesting actually to look at it. So basically the motivation of this work is that we know that earthquake is a very, very common type of, not very common, but especially from Indonesian point of view, because Indonesia is being surrounded by actually the Pacific Ring of Fire. So basically it is very, very vulnerable to the landslide, to the earthquakes. So the death toll, if you look at just from the data from 2015 alone, there is about 8,000, more than 800,000 people have been actually affected or have been killed due to the earthquakes. And not only the earthquakes, because of the shaking, ground rupture, landslides, and associated events that is being created by the earthquakes. And also not to forget actually the tsunami, which is also essentially is a byproduct of earthquake as well. So basically the problems are getting increasing because of the increasing complicated tectonics that is actually playing role. and also the probability of earthquakes, if we see that also getting increasing actually in the recent years. So basically some countries like Indonesia, Japan, US, and India, they are being very, and Turkey also, and Iran, they are also very vulnerable actually to the earthquakes. So although we cannot actually stop the earthquakes from happening, but what we could do, at least we could predict that which are the areas that is actually very vulnerable to the earthquakes for the future earthquakes, and so that we can probably better prepared actually, so that we could mitigate if those kind of events might occur in the future. So that is actually the major motivation of this study. So and if you look at actually the problem statement, when we wanted actually to do this work, what we saw that because today when you looked at actually the literature, there is no comprehensive actually GIS based earthquake based on assessment is being available. So, and also no major study has been conducted on earthquakes, especially using integrated technique. That means the GIS based and also machine learning and also data driven technique as well. So our contribution to this actually research was basically to develop a very sophisticated integrated machine learning and ensemble based technique actually to contribute towards the earthquake risk and vulnerability assessment. So so the study area, as I mentioned, actually this is the world map. Basically this is Banda Aceh. So there are two study areas that I would like to share with you. One is Banda Aceh, another one actually is the Palu. So Palu, as we know, that few years ago that we had also tsunami occurred there, and also there was disaster. I mean, there was massive death toll also had happened because of the, not only because of the tsunami, but also the liquefaction that happened actually in Palu area. So so let me just focus on actually the first study area, that is Banda Aceh. So as you can see, the Banda Aceh, basically what we did was we zoned or what we did, we divided actually the Banda Aceh city into 9 different zones, so that it becomes much more easier depending on actually the type of building and the type of material that is being used for the infrastructures that is being available actually in the city. So the data that use that input parameters that were used actually on this particular figure that you could see, there are different types of assessment that we have performed. For example, EPA is the earthquake probability assessment. And for that, the input data that we use as the slope, elevation, magnitude, density, depth density, epicenter density, proximity to fault, and geological information as well. And SSA is nothing but the susceptibility to seismic amplification. So in this case, we utilize the amplification factor, slope, and curvature. And EHA is nothing but the earthquake hazard analysis or assessment, whereby we use the PGA or peak ground acceleration and the intensity variations. And then also we perform the EVA or earthquake vulnerability assessment. In this case, we use different type of data such as the building density, road density, proximity to the road, stream density. So a lot of socioeconomic parameters actually were utilized in the vulnerability assessment. And finally, we perform the risk assessment actually. So essentially what we did was we use all this, we collected all this data and we applied actually the different types of methods that as I mentioned earlier, such as actually the hierarchical clustering and also machine learning based ANN method actually to perform the earthquake probability and risk assessment. So this is the overall flowchart that we use here. As you can see, the social vulnerability, structural vulnerability, and geotechnical vulnerability we perform, and then we combine, after performing actually these 3 types of earthquake vulnerability, then we combine them to come up with actually the final vulnerability map. Because of the actually constraint of the time, I'm not actually going into very detail, but this actually particular slide shows essentially what has been done to produce actually those vulnerability maps. So essentially by having all those input data, what we did actually, we applied the AHP based method, actually analytical hierarchy process based method, and we ranked the parameters and the layers actually, and then using the expert opinion and so on, and then finally we classify to produce actually the final vulnerability map. So this is actually the result from the analysis. As you can see, this is the social vulnerability map from the Banda Aceh city. This is the structural vulnerability map, and this is actually the geotechnical vulnerability map. So finally, we combined all these vulnerability map to produce actually the final vulnerability map. So this is very, very useful, so that at least we know in spatial domain that which are the areas are very, very critical actually, or is falling in the very high vulnerability zone. So then the next step, what we did was then we produced actually the earthquake risk map. And as you could see actually on the left hand side, so this earthquake risk map, and then we did the validation of the risk map, a very detailed earthquake risk map, and the accuracy we came up with is about 84%. So and as you could see that and also we estimated and we calculated that how much population that has been actually under risk. We could see that almost about 20% of the entire city is being falling under very high risk areas. And as far as the 4% of the entire city, and also about 20% of the, because it is a highly dense city, so about 20% of the population are still actually falling on very high risk areas. And so these sorts of information are very, very useful, especially for the disaster management purpose. Then the second study area that we did actually was Palu. So as you could see that Palu is sitting here actually, and then this is actually shows the earthquake events that has happened in recent years, starting from 4 magnitude actually to 8 magnitude. So this is actually the method that we use, again like in the previous case. So we use different sets of earthquake conditioning factors, and then in this case we use 2 different type of method actually to produce the risk assessment. So in this case we use the machine learning CNN based method as well as actually the ASP method, and we would like to see that which method actually produces much better results. So the different sets of input data that was used here, such as the elevation, then the depth density, then the magnitude density, then the PGF, peak ground acceleration acceleration variation, and also the intensity variation, then the epicenter variations, epicenter density, then the slope index, and the proximity to the fault, and geology. So these are the different data that have been collected, and then we produce them actually in the GIS. And also the other vulnerability related factors that was used were the building density, road density, proximity to road, then stream density, proximity to stream, and major visiting places, and also main official locations or building locations, and so on. So similarly, we use actually the ASP and the ANN based method actually to produce the different types of maps. So for example, these are some of the intermediate products that we produce, such as the susceptibility of seismic amplification, and the probability map, and the probability, and then the hazard map. From the probability we produce the hazard map, and also separately we produce the vulnerability map. So this is actually ultimately we calculated the risk map, as you could see on the right hand side. These 2 different types of maps basically was produced using 2 different types of method. The first one actually was produced using the ANN method, and the second one was producing actually using the AHP based method. So, and overall actually we obtained accuracy is about 85%. So as you could see, the entire coastal area of the Palu, basically we have done very detailed risk assessment, which probably would be very, very useful for overall disaster management purpose. So again, moving on, I would like to just quickly share another case study of seismic vulnerability assessment of Tabriz area, which is in the Iran. And in this case, what we did, we took actually the building materials, which is very, very critical, especially for the vulnerability assessment. So depending on the type of building materials, we produce actually the very structural and geotechnical vulnerability map of actually the entire Tabriz area. So as we believe that the next the next major big earthquake might occur actually either in Iran or maybe actually in Turkey. So basically these sorts of work are very, very useful, especially so that we know that how much of population and what are the areas that is basically at risk. So do we still have time? Maybe I can just quickly finish it up actually some other case studies. Let me just share some other case studies from landslide studies. So the geospatial tools and techniques not only are useful actually for probability, vulnerability, and risk assessment, but also it can be essentially used for producing the inventory map. So this is a case study from actually Malaysia, where especially in the tropical country, whereby it is very hard to produce a very detailed inventory, landslide inventory map. So in this case, what we did was, by using the multi-temporal remote sensing data or satellite images, in this case, very high resolution, not very high resolution, medium quality, medium spatial resolution satellite images, we were able actually to produce, or we could detect actually the landslides. So then again, using the different types of data such as the LiDAR imagery, very high resolution LiDAR data point or point clouds. Also in this particular case study, we contributed towards actually the producing or we automatize actually to produce a landslide inventory map. So essentially what I'm trying to say, actually this kind of data that can be, this kind of tools and techniques can be useful for landslide inventory, and also for inventory mapping, and also for landslide vulnerability and risk mapping. So this is another case study from Vietnam. This is where actually we have done the landslide vulnerability map, and in this case we use different types of neural network method just to find out actually which method produces much better result. So as you could see, both of this method, for example, Bayesian regularized neural network and also the Leavenworth marketed neural network, both these type of neural network methods produce fairly good amount of prediction accuracy. So such kind of actually, so in this map, what basically we are trying to show, we have indicated actually the area classified into different zones, or the landslide susceptibility index zone, whereby the red colors you could see where the future, in the future there could be the occurrence of the landslides. So similarly, we have also done extensive work on debris flows as well. So debris flow is nothing but is a type of mass movements actually. So in this case, we use, this is a case study in Malaysia. So so what we did, basically we used the LiDAR data, and from the LiDAR data, very high quality LiDAR data, we derive actually the digital elevation model, and from the digital elevation model, we employed actually the different types of geospatial tools, and then we calculated actually the maximum flow velocity, maximum flow height, and the maximum pressure, and the maximum momentum. So it is, I mean, by deriving these parameters, then finally what we did, we produce actually the debris flow, or numerical modeling of the debris flow. So as you can see here, if the debris source of the debris flows are known, then we can calculate that how far actually the debris flow are going to reach out, and how much material is going to carry forward as well. So these are actually some of the numerical modeling that we have done. As you could see that these are the tools that would be very, very essential actually for the disaster management purpose as well. This is a case study. Again, we performed actually the run-out distance modeling actually in the Cameroon highlands. Sorry, so something wrong. It's not working. My computer got crashed, I think. Can you all hear me? Yeah. So basically, I mean, that was some of my last slides. So I would like to actually conclude my talk here. For example, this is another case study here. So flood risk assessment. This is similarly like in the case of earthquake. So in this case, what we did, we took actually the land flood inventory mapping, and then we produced the hazard probability, and also finally we produced the flood susceptibility and also flood risk map. This is a case study actually from Iran. So I would like to conclude my talk here, because maybe I have already exceeding my time. So as you have seen actually during my presentation, so the combination of the geospatial data, especially very high resolution geospatial data, in tandem use of the machine learning, such as you know, the artificial neural network, deep learning, and also many of these actually ensemble models are very, very useful to produce the hazard and the risk actually assessment. So those sort of actually data and also the maps, they're very, very useful, especially for the overall disaster management purpose. So with that, actually, I would like to conclude my talk. Sorry that there was a technical glitch a bit in between, so that the slides actually didn't move forward. But I hope that you still could hear me. And thank you very much for listening to me. Thank you very much. So with that, actually, I conclude my talk. I think the next speaker actually probably can take on from here. So I see that is no information coming from the host.
Yes, Professor. Sorry, we have problem with our audio visual. So now we are go to the next presenter, Mr. Rizky Mardian. So this is a parallel session for keynote speaker. So this session now is for Mr. Rizky Mardian to present his presentation.
Okay.
Hello, Mr. Rizky.
Yeah, hello. Can everyone hear me? Yeah, I assume everyone can hear me, right? Okay. In that case, let me share my screen. Give me a moment. Okay. Am I visible to everyone or? Okay. I probably need to turn off my video just to make sure that the connection won't be interrupted. And I believe in the conference venue is already around 4 p.m. now. It's early in the morning here. I hope everyone's still focused. And yeah, so the topic that I'm going to talk about today is related to programming living organism. My name is Rizky Mardian. I'm a postdoctoral researcher at the University of Edinburgh, working in a genetic engineering / synthetic biology project. And because the conference theme is quite broad, actually I wasn't entirely sure like how should I deliver the talk. I think mostly the slides that I have here is going to be like introduction to what genetic engineering is, what like people in synthetic biology do, and maybe like towards the end of my talk, I will present 1 or 2 slides about work that I've done in the past. So this is probably like my favorite slide to start my talk. Like in 2016, one of American writer, futurist, wrote a book called The Singularity is Near. And in the book, he predicted that in the next decades to come, there are like three major technological revolution that will change human life. There are robotics or artificial intelligence, which I believe everyone should be familiar with this term nowadays, and especially from Professor Pradhan talk, we already heard about the application of machine learning in geography, geology domain. And I believe like there's so many other application of AI out there in different kind of study. And then the second one will be genetics. I believe nowadays, especially for the last 2 days, people uh, got more familiar with, for example, at PCR. I believe everyone knows about it. It's basically one of the workhorse technique in the molecular biology lab that people can use it so many different application. And then the third one is going to be nanotechnology, which is in very loose term is just a science to make things smaller and smaller. One of the obvious example, for example, a computer hard drive that maybe like 10 years ago, 20 years ago, it took the whole room to store a very small amount of data, but nowadays you can get as small as a USB thumb drive up to 1 or 2 terabyte. So why I'm bringing up about this, because for some reason, talking about like my previous encounter to different kind of research in the past, I have studied, I have exposure to both to three of domains that I just mentioned. I actually started as computer scientist, and then studied robotics, mostly in the mechanical engineering side of it, and also like did some computational modeling as well, to simulate the behavior of distributed robotics. For some reason along the way, I was involved in collaborative research where instead of implementing this smart algorithm in a mechanical device, we wanted to do it in biomolecular level using DNA as a material to carry and simulate the computation. And then like from 2016, again, for some reason, I shift my research topic towards like more biological domain, where instead of just using DNA for non-biological purpose, we were uh, we were trying to build computation inside living cells, for example, like using bacteria and any microorganisms. So really, like as a computer scientist, like they are like basically two separate but slightly related field of technology, where we can use biomolecular material to perform some kind of computation and information processing capability. The first one, as I mentioned, was using DNA to carry signal that is in terms of biomolecular material such as DNA, but not for biological purpose. It's mostly for building structure, um, and using like as simple as a hybridization principle to simulate the information processing capability. While the second one, like really to insert biological program inside cell, which is called synthetic biology. So my talk for the rest of my slide probably will be focused on the second part, which is the synthetic biology instead of DNA nanotechnology. So a bit of background of what DNA is. I believe like everyone should be familiar with this. DNA basically, in a very again like in very loose term, you can imagine as a chain of phosphate backbone with 4 different base that That is adenine, thymine, cytosine, guanine, which complementary to each other. For example, A is always paired with T, C always paired with G. So DNA is, where's the DNA located in human body? A collection of DNA will form a gene, and like it will be located inside a chromosome, which is located inside cell in any living organism, basically. And as computer scientists, probably what we are interested most is just like how the information is stored inside DNA, which is represented by the sequence of the 4 bases, CGAT. And the idea is how we can manipulate the sequence of a string or nucleotides in order to perform like computational behavior. And yeah, just some fun fact about how many DNA and genes that we have actually inside our body. So in order to perform the computation, basically, naturally speaking, our body already like perform some kind of like computational mechanism in processing, like from DNA to RNA and then to protein, which is pretty much dictates how our body function. Um, some technical term for this called central dogma of in biology. I believe probably everyone heard that before. In a very high level, it's as simple as moving on from one state to another, that we call like from DNA to RNA. It's called a process called transcription, and then from RNA to protein, well, we call it as translation. And the idea is how can we control the behavior of the cell by introducing or manipulating the production of a certain protein, which is pretty much dictated by the sequence of the DNA itself. And this is just to show that, like, basically protein is made of amino acid, that they are like 20 different amino acid that can that can form a certain protein that could fall into a functional protein. And as an engineer, of course, it's probably going to be a bit difficult if we are going to manipulate or design the DNA sequence without having any kind of abstraction. So shown here is the visualization language that people in synthetic biology use a lot to represent a functional unit that we can utilize to design like bigger like complex system. So at least a transcriptional unit should consist a promoter, where the starting region for the transcription to begin, and then there will be RBS, where the translation from RNA to protein is gonna occur, and then the gene and the coding sequence of the gene itself, which pretty much they will encode the information that we want to represent our signal with, and then the terminator will be the region in the DNA where the transcription process will stop. So then the next question is, if we can somehow redesign our gene, we can synthetically like build any kind of genetic construct. How can we really make a quantitative measurement out of the biological design that we have? One of the most popular technique is called flow cytometry, where basically is a device that emits some light that will excite the cell that is flowed through the chamber, and then it will the machine will capture the the light scattered from the cell, so that we can get a rough idea how the size and the granularity of the cell. And then by taking all the population data, then we can get quite like insight on how the whole cell population behave. Most important thing is that in order for this technique to work, we should probably use a certain fluorescence protein that can emit different with length of light. So for example, we can use like some of the most common fluorescent protein that people use nowadays in the lab. You can use like blue fluorescent protein, green fluorescent protein, and all of them have a different wavelength that you can specify in the machine, so that by looking into the histogram of how this light is scattered, you can basically quantify the behavior of the population. This just to show like how the protein looks like if you take the picture in dark room, for example. And really, like one of the most exciting achievement, if I can say so, that in probably like around 10 years ago, some people tried to insert the gene from like jellyfish, the green fluorescence, into cat, and make the cat made the cat glow in the dark, actually, by doing that. This is just to show that actually we can cut and paste DNA from one organism and put it into another, as long as like most importantly, for example, like the whole function, we have to make sure that will not be interrupted. And it's actually not entirely new thing. Like in the US, for example, like there has been like so many companies doing like genetic engineering, and even the concept of genetic engineering itself like has been around for almost 100 years now, like 70, 80 years now. And mostly the application that people have done so far, maybe in agriculture. You have heard about like genetically modified organism, like crops and so on and so forth. And of course, because they are not like naturally evolve in that way, there should be like some regulators that control what is allowed to do, what is not allowed to do. And now, in my research, actually, I was not working in the agriculture domain, but it's more like simulating the computer behavior inside cell. So here, just diagram how the computer circuit looks like. But as we know, like in electronic computer, everything is built with silicon, and then all the signal is controlled by the electronic current. One means an on signal, and zero means like an off signal. And we know there are like a variety of different logic gate, which in a way, like if you arrange them all together, you can arrange the signal so that you can perform such kind of computation. It could be an OR, AND, XOR, NOR, NAND, and NOT. For example, with NOT gate, if you have like on signal as an input, the output will always be 0, the complementary of it. With OR, for example, if you have like at least one on signal, the output will always 1. And with AND, you have to have like 2 input signal to get an on output signal. So yeah, putting all of this together, we can design pretty much everything, perform computation in electronic circuit. Yeah, everything is represented as 1 and 0. That's why in very low level, if you code something, if you build a program, it will be translated into like binary instruction. that would be converted to a electronic current. This is probably just a repetition from what I just mentioned just now. And then this is the example how you can, for example, build binary adder, 4-bit adder machine by combining all different gates together. And like in 1960s, Apollo 11 circuit actually built on top of only NOR gates. So theoretically, you can build any kind of circuit using only NOR gate, and they did it in Apollo 11 circuit that went to the space, only built on top of the like around 5,600 NOR gates. But then again, the question is how we can do this with biological system. Maybe I can just skip this. This is just like some consideration that you need to worry about, like when working with biological system. You have like different kind of like biohazard level, but mostly in my research, we don't really need to have a biosecurity that very high. We can work with BSL1 basically. And basically when working with biological system, it's similar to like cooking, for example. You just need to have instruction. You can imagine like recipe, how you can put all of the ingredients correctly and at the right temperature and so on and so forth. And the organism that we are using mostly like E. coli, because it's quite simple. It's relatively simple actually. What we modified basically the plasmid that we inserted into the cell. And as I mentioned, like we basically abstracted everything in promoter RBS gene terminator sequence, and then we put together as a linear DNA, put into the plasmid and transform them into cells. So the idea is, for example, we have like some abstraction now. Can we really build a building block using this DNA that we call it DNA part? You can imagine it like a Lego, like clipping, for example. You cut and paste all the interesting component out of a template, and you put together in a new place. Yeah, I can just skip this. And this is just like, again, to repeat. So basically synthetic biology, the whole purpose is to redesign biological system to mimic what people can do with electronic computer and any electronic device. Basically, like in computer, you can take input signal. You have like central processing unit that can convert it into output signal that you expect. And then the same thing with a biological system. And now the input could be any kind of chemicals, small molecules, light, heat, or antibodies or antigen. And the whole idea is how we can build a logical logical function inside the cell so that we can manipulate the output that we want, typically the type of protein that we want to be produced. So in the future, the idea is if people can code and like build a mobile app just using something like certain programming language, we can also do the same, but now we do it inside cells. And that's we actually did actually in our lab in 2016. Maybe I can just skip the upper part, but the whole idea is we build a software a platform that basically take a high level programming language following syntax of Verilog. Is like quite common and popular language in electronic circuit design. And then the software will do automatic design of how it can be translated into linearized DNA that we can cut and paste together and like insert into cells so that the behavior that we specify with the Verilog can be implemented in the cell. So shown in the right side here is, for example, the gate, the schematic that we have in the middle, and the in the blue line, the solid line is basically the output predicted by the simulation, and the black one is like when we measure the actual biological program inside cells. And yeah, so basically here just to show the comparison, like in designing electronic circuit, probably nowadays people don't really do it by hand anymore. We also do the same with biological system. Instead of representing everything in abstraction that people use in electronics circuit, we use the ASBOL visualization, and we can convert it into a plasmid that we can just insert into DNA. So imagine like a Lego, for example. You have like components that if you want to build like different kind of structure, how you can put all of these unique components together, and then you basically can also do that with genetic parts as well. Probably just gonna be a quick because I think I'm running out of time. So this is just like other application that we did back in 2016 as well. So we got funding from DARPA to produce like molecules that never existed in the lab using this technique before. So the idea is like taking some part of gene from different organisms, put them all together. Can we produce certain molecules that like entirely new in the nature? And personally, also like built software based on data analytics and machine learning that basically take the biological data, the design, and what the measurement we put together on like bunch of different machine learning algorithms, try to predict what kind of behavior we could expect if we combine different kind of gene at the same time. Because like if we do it in a lab, it will take a lot of time, a lot of try and error, and sometimes it didn't work. And yeah, just another application that we also can use the modified bacteria to, for example, like detect something in soil. For example, if they detect like some chemicals or biological material, it will activate the protein that is tagged with maybe like some colors, and then it will emit some colors in the presence of those molecules. And in 2018, if everyone heard, in China, actually, like there was some researcher that actually tried this in human, even though it's probably like quite unethical at the moment, because still long way to go before we can try this in human. I believe like I can just quickly skip this. This is just like some research along the line of the study. And yeah, in fact, even in human, there's a lot of mutation actually that can improve the functionality of our body. For example, some people actually have like stronger bones. Some people can see a lot more color than others, have like bulkier body, and so on and so forth. And the question is it possible in the future this kind of technology we can use to modify our genes in order to get like certain traits that we want to enhance ourselves? But then the question is, maybe like it's a long way to go. At the moment, we play around with the model organism, with E. coli, yeast, and some people do it with mammalian cell, but still like a long way to go to really do it in human. And another question is like, is it ethical? Is it socially acceptable if we like modify human, for example, which is in 2018, like some people, some researcher in China like got banned from research by doing that. And then how about in Indonesia? Because I think like one of the potential that we have, like we have a really diverse. The biodiversity in Indonesia is really really high. This probably could be an advantage that we can explore in the future. I guess that's pretty much what I'm going to talk. Again, like sorry, probably I running out of my time, exceed my time. With that, I would like to thank everyone. Yeah, thank you.
Thank you very much, Dr. Rizky Mardian.
Okay, I think now back to the committee, or the next speaker probably will want to take over.
Thank you very much, Dr. Rizky Mardian. Now we move to our last presenter, Dr. Mika Fisher from University of Hawaii at Manoa, with the title 5 Dilemmas in Building Climate Resilience. You have at least 20 minutes to present. Please, Dr. Mika.
Great, thank you. It's great to be here. Can I have access to sharing my screen? Okay, here we go. Can you see my screen? Is it in presentation mode? Can somebody confirm? Okay, let me start from the beginning. Yes, as was mentioned, my presentation is titled 5 Dilemmas of Participation in Building Community Resilience, a guideline for working with communities. And it actually really connects to the first presentation today from Professor Pradhan. You know, the types of engagement, the amazing technological capacity to be able to understand natural hazards is quite remarkable. And I just want to state how impressed I am with that sort of work. And I'm going to be continuing based on that type of research and engagement. And so just very quickly about myself, I'm a research fellow from the East-West Center. I'm also a faculty member at the University of Hawaii, affiliated with the Urban and Regional Planning Department. I'm core faculty at the program for disaster management and humanitarian assistance. And I've been working for many years in Indonesia with numerous universities, specifically Hairun University, on developing teaching materials with universities to do kind of a knowledge to action approach. So here you can see some images of some of the workshops that we did in Ternate. And what we wanted to do was to really understand how we collect and convene the key information about natural hazards and how that then influences decision-making processes. And the questions that really drive this research that I'm talking about today is really a question that emerged from the participants. So the more that we engaged with people on developing these workshops, trying to think about how we do hazard assessments, how we do vulnerability assessments, how we do risk analysis, what the key question that continued to emerge over and over again was, how do we communicate this with the communities that we're engaging with? How do we take this incredible technology and the capacity to process data and make that relevant for local communities? How do we get local communities to be the partners in the processes of building resilience? And what I'm going to highlight today is 5 overarching dilemmas that we kind of arrived at after 6-7 years of doing workshops with universities in Indonesia. And the model was quite unique. What we would do was we would begin with working with Hyrule University, collecting data, village level data or even lower, and trying to map out together with different multi-stakeholder groups. And when we did that, we began to understand, what is the climate data? We were able to downscale information. What is the local hazards? And then we would start to go into the communities, as I showed you in this previous slide, and start to talk with people. What are the things that are the most challenging for communities? So for example, in Ternate, when you look at a hazard and risk profile, and we had top volcanologists on our team, that would say, the scariest thing that could possibly happen is an explosion of Mount Gamalama in Ternate. But if you talk to people in these communities, in working with these communities, talking about what hazard or what impacts them the most, everybody pretty much said it was flooding. Flooding was the biggest issue that people considered as kind of a burden to their lives and livelihood. So there was this interesting dilemmas of how do you really make sense of the issues of risk and vulnerability, and how do you begin to start doing something about it? And more broadly, what should people who want to engage with communities, planners, what should universities do? How do you do the outreach? And what we began to understand was that there is really not enough research in how we not only communicate, but how we meaningfully engage communities as our as our partners. So the presentation today is structured in a series of dilemmas. And the first dilemma is, how do we present ourselves to vulnerable communities as authentic partners? And this is really important because lots of outside initiatives have come to these communities. So when you walk into a community, how do you understand the way that you're being viewed? Right? Are you viewed as an anonymous bureaucrat? Are you viewed as somebody who hasn't responded to the challenges of a community in the past? Are you viewed as somebody who's a consultant implementing something? Are you part of a private sector initiative? So the way that we interact with local communities and make them our authentic partners is really a fundamental issue that is really important. And this is very much related to timescales. Are you just working on a specific project that's going to end, or is there going to be greater longevity in terms of how you work together to approach building resilience, for example? And one of the findings, obviously, here is, a lot of the research talks about building trust. But specifically for planners who are engaging with local communities, it's key really to establish the expectations about roles, right? A lot of outsiders, especially high-level government officials, come in with a lot of hubris, the promise of a lot of budget, power relations are key here. And being clear about expectations, about roles, responsibility, about what the terms of authority, what the overall objectives are really, really important. And a lot of the participation literature really talks about settings. Where do you want to have conversations with people? How do you help people to feel comfortable? So this is really a big dilemma, right? How we first interact, how do we present ourselves to vulnerable communities as authentic partners? The second dilemma that I'd like to raise here is, how do we earn and maintain that community trust, right? So especially here, I'm from the University of Hawaii. In Hawaii, not everybody thinks as a planner, right? Not everybody can scale out and think in terms of cause and effect. And we show them maps and models, things like that. Sometimes communities are dealing with a lot of hurt, right? And this is true in a lot of places where a project, government officials or programs and budgets are supposed to be allocated to perform a function, but a lot of the resources may get diverted to someone else. And sometimes in community meetings, people shout and get animated and get angry. And sometimes that is part of expressing these history of what we call non-engagement here. So we may know about these issues, but you might come into community and not be aware or be misinformed about the level of trust between outsiders, planners wanting to implement an initiative, and those local contexts. And one of the, we set this up in terms of problems and solutions, and trying to give planners who want to engage meaningfully with communities some tools about how to do that. And they're really, really straightforward, right? Keeping your commitments, even about small things. A lot of times people say, yes, I'll get you that document. I'll get you that regulation. I'll show up on time. These small things really set the tone about the extent to which you are exuding that sort of commitment to work with local communities. I understood I had 10 minutes, so I'm going to go very quickly through my slides. And if anybody has questions, if there's extra time, please let me know. The third dilemma here is, what do we want from community engagement? Right? We want to make communities more resilient. Lots of planning initiatives, right? Around the world, tons of budgets, climate adaptation funds, municipalities committing to doing adaptation. So the question is, we really often don't think about what we want by community engagement. Are we wasting people's time because they have to go to farms or they have to go to work to conduct these public meetings? Which parts of those communities are we listening to more than others? So what do we want from community engagement is really the framing of the question for this third dilemma. And I think it's really about trying to figure out questions that help to better understand local knowledge and connect with values, right? And that comes through a lot of practice. These things may sound very, very straightforward, but there's really an art and a skill to being able to listen for meaning, to be able to capture what a community or an individual or a family is trying to say, and how then planning processes are able to capture and act based on that, particularly if you are interested in engaging with those communities that are at most at risk and those that are most vulnerable. Moving on to the fourth dilemma is, how do we listen effectively for meaning and understanding? And I already touched on that, but oftentimes planners and disaster professionals come in with this idea of risk, especially in Indonesia. There is a policy that really articulates a formula, right? But if you're talking to a local community member who's dealing with chronic flooding, and you say, well, vulnerability equals exposure times sensitivity divided by adaptive capacity, that is not the best way of being able to capture what the key concerns are for a community. And maybe those frameworks, the vulnerability framework, is extremely valuable for being able to conduct this sort of analysis. But that translation that happens from expressing what a community's concern is and how that's then integrated into the types of analysis that is actionable, that influences what types of budgets and what type of processes get implemented, is really, really significant. Communities really want to be acknowledged. They want to be listened to. They want it to be taken seriously. So when we come in and we say we know better because of climate analysis that's coming from somewhere very far away, it really shifts the power dynamic, and also influences the likelihood to which local communities would be actively engaged in helping to build community resilience in ways that are often targeted towards supporting these communities, or the intent of them are supposed to be doing those things. So we talked about these in a lot of the workshops about how do we approach this? How do we take the time to listen carefully to the stories? How do we understand the ways that they're being told? If people are upset, about a certain situation, what is going on behind that? Or if people are silent or reticent to share, what could possibly be the reasons behind that? And how do we then interject to be able to understand and listen for meaning? Finally, the fifth dilemma that I want to raise here is, to whom are we accountable in community engagement? What is the nature of that accountability? So a lot of times when planning initiatives are engaging with local agency, are implemented through local agencies, or a university is working with a community, or private sector, there's a lot of private sector CSR programs that are trying to support communities in a lot of places. We are part of that process, right? Again, this research is really about the people who are trying to make sense of how to implement these initiatives, right? We know what may be happening. How do we do that engagement? So we need to understand how we work, and we are situated in a web of formal and informal obligations. We might be contracted to implement something by the government, but we also have these informal obligations of how we take people's time, how we respond to their concerns, and how do we follow up on those commitments, right? So it's not just I'm responsible for producing this report for this project for which I am paid for, but there are many other informal obligations that take place when you begin to interact with local communities. And we don't spend enough time thinking through those processes. Take the time to do it right. And often this takes long-term sustained engagement. How do we continue to show the commitments to the priorities if a local community is meaningfully trying to build resilience through the institutions that are supposed to be approaching how to protect them? There's many constraints in doing this, obviously, and there's many different dilemmas that happen within this dilemma. But I think that working with integrity really requires us to be always attentive, paying attention to the expectations that we are creating and the obligations associated with those expectations. So that's my short presentation today. And I just really wanted to reinforce the point that we are often tasked with conducting vulnerability assessments and conducting the analysis. And what I wanted to highlight in this talk today is really, how do we then operationalize those analyses? How do we work with the communities? And what are the things that we need to think about when those plans get mobilized and influence local communities? So thank you very much for the time today and for the invitation. It's really great to be engaging with Hiram University again, and I really appreciate all the work that you do. Thank you.
Thank you very much, Dr. Fisher. Now is the time for questions. Please.
I'd be happy to answer any questions if there are any questions for my presentation. If you want to just put it into the chat, please go ahead.
Dr. Mika, can you hear the questions?
I have not been able to hear a question.
Ibu Nani asking about how the people in Ternate still feel comfortable living in this dangerous island without any assessment or mitigation system to themselves.
So what I heard was how do the communities in Ternate that are vulnerable, how do they feel about not having vulnerability assessments? Is that correct? Can you
Yes.
can you restate the question? That's the question. Well, I think Ibu Nani has done some fabulous work in Ternate, and I think our partnerships working with Ternate, and we've invited, the rector and local community leaders and researchers for many years here to the University of Hawaii to look at each other's systems, right, in terms of how we think about resilience and how we address issues of vulnerability. And what I'd like to say about this is that I was really impressed by the commitment of the researchers to working in disaster risk reduction. And I think it's a question of scale. I think working with local villages is incredibly important. So anytime there are initiatives to sit down with local communities to talk about what concerns them the most and to connect that with decision makers that can do something about it, I think that's already a very, very remarkable success. But when you begin to scale it up at a municipal or at a provincial or a level, the stakeholders that are involved become extremely more complex. And there are many more questions about how you address these type of themes. And I really like the inductive approach that we had been working on through those short workshops and actually producing pretty accurate vulnerability assessments at the village level. And so doing a series of that and scaling that up and working across local communities to understand those concerns better and to develop innovative solutions towards addressing them would be really, really meaningful. And I think, with the technology available and the data that you have on hand, it's really a process issue, right? I don't think there's any limitations in terms of the analysis of what people want to do to understand the concerns that they have for their families and local communities. So I think keep doing what you're doing and try to build in new partnerships and new perspectives into addressing those kinds of things would be my reaction, much less an answer, but my reaction to your question. Would it be possible to ask a question? I'd really enjoy being able to engage with Professor Biswajit Pradhan about his research. I find our research to be kind of the corollaries of one another, and I'd be really eager, if I can, ask. What are the biggest challenges in terms of engaging with different stakeholders? I mean, such impressive analysis from Aceh at different scales of Palu, all these different locations and wonderful case studies. What are some of the challenges that you've faced in getting people to be mindful of the key issues that they're facing?
Hello, good afternoon. We are very sorry for the connection here. I think the moderator has logged out. For Professor Biswajit Pradhan and for Micha Fisher and Rizky Mardian, thank you very much for your presentation today. So I think we will end our
Okay, I've lost audio. It seems like we are wrapping up the session. Thank you very much for inviting me. I really appreciate everything. Take care, everyone. Bye-bye.